is a lesson for Algebra 1, Day 12, Multiplication and Division Properties of Exponents. The first of three properties we're going to look at is the multiplying powers with the same base. Then we're going to look at dividing powers with the same base. And then we're going to look at powers of powers property. First one, multiplying powers with the same base. If you have the same base and it's being raised by exponents, and there's a multiplication operation between the bases, then you would add the exponents together. So a to the m times a to the n is going to be equal to a to the m plus n. Like in another example, let's say we had x squared times x to the third. Bases are the same, it's x, keep the base, add the exponents, x to the fifth power, 2 plus 3 is 5. That would be your answer. Same thing would work if you had numbers. Let's say it's 2 to the 5th times 2 to the 6th. You would multiply those together, you get 2 to the 11th power. You could also combine exponents and bases. You could do 2 to the second time, or 2 to the second x to the third times 2 to the fourth x to the sixth power. Work on your numbers first. So 2 to the second times 2 to the fourth is going to be equal to 2 to the sixth power. X to the third times x to the sixth is going to be x to the ninth power. That would be the answer. Now you could multiply 2 across, but whenever the exponent is 5 or more, for now don't multiply it out. It will take you a long time. I don't think you need to at this point. Another example, let's say we had 3y to the 11th power times 12y to the second power. So in this example, the 3 and the 12 aren't the same base, but you could still multiply them. 3 times 12 is 36, and y to the 11th times y to the second is y to the 8th power. So those are basic examples for multiplying powers with the same base. Here are the examples we did in class. The first example, 11 to the 4th times 11 to the 3rd. This is just like saying same base, 11 to the 7th power. Next example is n squared times n. The imaginary exponent that's there is 1. When we don't see an exponent there, it's 1. So n squared times n to the first power is going to be n to the third power. And that's it. Number 3, 11n squared times 3n to the fourth. It's like saying 11 times 3, which is 33. N squared times n to the fourth is n to the sixth power. Next one, we got 2 to the third times 2 to the third x squared times 2 to the fourth x to the sixth power. Start with the coefficients first. 2 to the third times 2 to the fourth is going to be equal to 2 to the seventh power. X squared times x to the sixth is x to the eighth power. And that's how you use the multiplication properties. Continuing on here, dividing powers with the same base, just like before. When we have the same base and it's being raised to a power and the operation is divide, then you would subtract your exponents. So, for example, a to the m divided by a to the n is equal to a to the m minus n. Another way you could look at this is a to the m divided by a to the n, which is equal to a to the m minus n. One first example you could look at is x to the sixth power divided by x squared, which is equal to x to the fourth power. Or you can use coefficients, 2 to the 7th power divided by 2 to the 5th power, which is equal to 2 squared. And 2 squared, of course, is 2 times 2, which is 4. Your next problems will look somewhat like this, where we have a fraction. The fraction represents a division problem. And when we work with fractions, you go one number and one variable at a time. So for example, you could start off with 3 to the 7th power x squared y to the 4th. Let's say that's our numerator, and the denominator could say 3 to the 6th power, x to the 4th, and y squared. At first this looks really scary, but all we need to do is focus on our one base at a time. So let's focus on the 3's first right here. The trick to this is to take the smaller exponent, which is 3 to the 6th, cross it out. We just took away 6 from the denominator, so we're going to take only 6 from the numerator. So 7 minus 6 is 1. So we have 3 to the 1st there. Then you should rewrite your fraction underneath. And since we have 3 to the 1st left on the numerator, 3 to the 1st, we're going to leave in the next part of the problem. Then we have x squared and x to the 4th as our next variable. Cross out x squared, take away 2 from 4, which is x squared. That's in our denominator, so we leave x squared in our denominator. Next variable is y. We have y to the 4th and y squared. Take away y squared since it's smaller. Take 2 away from 4, which is 2. So we have y squared left in the numerator. This would be your final answer right here. Looking at some examples. Number 1. We have 2ab to the 5th c squared over a cubed bc squared. Working on our coefficients first. We have a 2 in the numerator and 1 in the denominator. We can't really do anything with that 1, so or the 2, so we're just going to bring the 2 down to the numerator in our answer. Then looking at the a's, we have a to the 1st power here, of course, because there's no power there, so we know it's a 1, and a to the 3rd in the denominator. Cross out the 1, take away 1 from the denominator, we have a squared in the denominator. Next variable is b. B to the 5th is in the numerator, b to the 1st power is in the denominator. Take away 1b from the denominator, take away 1 from the numerator, we have b to the 4th that's left in the numerator. And lastly, our c squareds. We have 2 c squareds, they cancel each other out. C squared cancels c squared out, so all that's left is 1. So this is our final answer here. Number 2. Looking at our coefficients first, we have 3 over 9. So take away, 3 goes into 3 once, 3 goes into 9 3 times. Putting these in our answer. X, we have 1x here, 1x from the bottom leaves x to the 4th in the denominator. Y's, we have y to the 17th and y to the 15th. Y to the 15th is smaller, take away 15 from the numerator. We have 2 left, so it's y squared. And then z to the 20th over z to the 28th. Take away 20 from the numerator, 20 from the denominator. We have 8 left in the denominator, so it's going to be z to the 8th in the denominator. Now this 1 in the numerator, you could just erase that. It's kind of redundant that it's there, so not really necessary. If you want to leave it there, that's fine, but it's better just to take it out. It looks cleaner because we assume that there's a 1 there in math. Continuing on, number 3. Number 3. We have 12 over 8, x squared y to the 6th, in the numerator, x to the 4th, y to the 7th in the denominator. 4 goes into 12 and 8. It goes into 12 3 times, it goes into 8 twice. So in our answer, we're going to have 3 over 2. We have x squared here, take away squared from the denominator, we have x squared in our denominator. We have y to the 6th, take away 1 from the denominator, we have y to the 1st power. Since it's y to the 1st, we can just leave it as y. Here's our answer. Continuing on, powers of powers property. Whenever a power is being raised by another power, you raise the power and you multiply. So again, you just multiply the powers together. So when we have a to the m raised to the n, you multiply m times n. So for example, it said you had x to the 4th power raised. All of that was raised again to the 3rd power. This is like saying x to the 12th power. Okay? So let's work some problems out. Number 1, x to the 6th raised to the 3rd. It's like saying 6 times 3 is 18, so we just go x to the 18th power. That's a horrible looking 18. Let me try that again. 2. A to the 4th raised to the 7th is a to the 28th power. Pretty simple. Number 3. This is a little bit more tricky. You have to look at this one very carefully. We have a multiplication sign between the c to the fifth and c to the third, and then we have an exponent raising this c to the third. So we do apply PEMDAS first. Okay, so our order of operations is very important in all our problems. And we ask ourselves, are there any parentheses? There are, but there's nothing I could do in this parentheses, first of all. So we can't really do anything, so we cross that up. Now there's exponents next. Are there any exponents? Well, yeah, there's an exponent here, but this c to the third is being raised by another exponent, which is -2. So we want to work on that first. So c to the third raised to the -2 is c to the -6th power. Keep that in parentheses, bring down the multiplication sign, and c to the 5th power. Now we could work out our multiplication. C to the 5th times c to the -6th, that was like earlier. We have c to the -1st. And remember in the previous lesson, when we have a negative exponent, we flip it to make it positive, so it's c to the 1st, 1 over c to the 1st, or just 1 over c is your answer. And that's your lesson for today.